Imagine a hidden world of life right under our noses, or drifting in the cosmos that we cannot see. What if living organisms exist today on the earth or beyond in the plain sight but invisible to us? Perhaps life has a twin shadow form that we never recognized. This is not science fiction, it is the scientific idea of the mirror life and the shadow biosphere. Life built from the mirror image of the molecules we know. At the heart of this mystery is a chirality or molecular handedness. Many molecules come in two shapes that are mirror images of each other, like your left and right hands. In the life on Earth, this handedness is strikingly one sided. All our proteins are built from left handed amino acid, and sugar on our DNA, RNA are right handed. In other words, our biochemistry has picked a handedness. Life chose one orientation of these mirror molecules. We don't know why life went this way, but every living cell on Earth follows it. As one source explains, our body, in the common with all other life forms, only use left-handed, which is amino acids. Right-handed amino acids are simply ignored. Because nature offers both hand, this means in principle you could flip life's chemistry. The diagram above shows how a molecule and its mirror image are chemically identically except for handedness. The curious thing is, life's molecular machinery can't use the wrong hand. Your body would reject the right-handed amino acid, just as your left hand can't fit in the right-hand glove. This asymmetry hints that mirror image form of life built out of right-handed amino acids and left-handed sugar might exist, but we simply won't recognize it. Now imagine life constructed entirely from these mirror molecules. That mirror life or mirror image life. Chemically, it would work the same way: DNA like molecules, proteins, cell membranes, but with every building block mirror. A mirror life form would read right handed amino acids as we read the left handed ones. To our eyes and instruments, it might appear inert because none of our standard tests would detect it. In fact, researchers have noted that our techniques are tuned to earth-handedness, so mirror-like organisms could be present all along, and we would miss them. For example, if you fed the wrong-handed nutrition to a mirror microbe, it simply wouldn't grow, and we would assume the sample was non-living. This means mirror life is effectively hidden from us. Some scientists call the possibility that such life exists alongside us the shadow biosphere. Under this hypothesis, Earth could host two parallel biospheres: the familiar one of the DNA and the left-handed amino acid, and the shadow biosphere of the alternate biochemistry. If the mirror-like microbes scurry in the remote corners, extreme deserts, toxic lakes, and deep soil, we might never have spotted them because our assays give no signal. Our labs would simply dismiss them as sterile. Why is it important? Because mirror life could change everything we think about life's rarity or ubiquity. If life can emerge with the opposite chirality, it likely emerged more than once. Our physicist Paul Davies notes, if life started more than once on Earth, we could be virtually certain that the universe is teeming with it. If a shadow biosphere exists here, it means life's origin is not unique or fluke. Multiple genesis events could be normal. This drives home the point that life might be common throughout the cosmos, just possibly in the form we haven't been looking for. It also means we might be missing real alien life. The Mars rovers and future probes are hunting for the familiar biosignature, DNA, left amino acids, etc. But if Mars or another world harbors mirror life, it might slip under our radars. As one astrobiologist explained, finding amino acids of the opposite handedness on Mars would be a smoking gun. That maritime life is truly alien and not just bacteria stowaways. In other words, molecularity would be proof of separate origin of life. The shadow biosphere is a bold idea that Earth's weird life could be a microbial organisms with a different chemistry. Colorado University philosopher Carl Klind and others have suggested we might share a planet with the life form that have completely different biochemistry from the once shared life as we currently know it. They could use different combinations of amino acid or even alternate genetic bases, and crucially opposite chirality. We see some hints. For example, researchers have wondered if mysterious phenomena like desert varnish might be produced by the unknown microbes. We have tools to spot only life that matches our chemistry, so a mirror biosphere might leave no obvious fingerprints. In fact, Carriage Venter observed that we are looking for life on Mars and we don't even know what's on Earth. The search for the shadow biosphere is a controversial, but it reminds us that our notion of Earth life centric. If alternate life microbes exist, they could be underfoot or inside us, completely undetected by the routine test. The possibilities of mirror life has direct implication for space exploration. Take Mars. NASA's Perseverance rover is carefully analyzing rocks for the organic molecules, looking for any signs of a past or present biology. It is a sophisticated lab on the wheels, but it's tuned to our biology, and so far it has found organics, but not definitive biosignature. If Martian life ever existed with the reverse chirality, Perseverance might overlook it. As one expert noted, if life on Mars uses the opposite-handedness, it would be clearly be separated origin of life. That would be a revolutionary discovery, but only if we have right detective tools. Beyond Mars, icy moons like Jupiter, Europa's, and Saturn's Enceladus are prime targets. NASA studies show these moons have vast liquid oceans under their ice. Laboratory experiments suggested that the basic building blocks of life, like amino acid, could survive near the surface of these moons, despite the harsh radiation. If life is bubbling in those oceans, future landers might only need to drill a few inches to find it. The catch is, if that life uses unfamiliar chemistry, opposite chirality, or our instrument must be designed for it. This idea stretches even to the exoplanets. Astronomers have found thousands of planets around other stars. We hope to detect life there by signs in their atmosphere. But what if an alien biosphere there started with the mirror-handed molecules? It could produce stable atmospheric signals different from what we expected. The broader point is inspiring. If Earth life isn't the only recipe, then thousands and hundreds of billions of planets might have a chance to prove life in some form. As one scientist put it, finding mirror life on Earth would mean life emergence was practically guaranteed on any suitable planets. The idea of mirror life may seem strange, even unreal, but it's a testable possibilities. Scientists are developing clever ways to search, from building synthetic mirror RNA in the lab to design probe that detect both hand biochemistry. If mirror life is ever confirmed, it would be one of the most profound discoveries ever. Not only we would find new organisms, but we know life evolved more than once. Life would no longer be one-time wonder of Earth. It would mean the universe is richer, more creative than we imagined. In that moment, our philosophy and our place in cosmos would shift. We would know we are not alone. Even our own planet would be host to two distinct stories of life. And if mirror life exists out there, among exoplanets or in icy depth of the moon, it would mean the galaxy is humming with life in the way we never anticipated. The search is on, and who knows what surprise the tiny macros of the shadow biosphere may hold for us.